Dear friends, we are going to discuss about the SAR of the H1 antagonist. Already we studied the first generation, second generation. In all the compounds we observed that there are the bulky groups are present. Bulky groups are nothing but phenyl rings, especially like a benzene rings. Two aromatic rings are there. What it will be indicate? The more aromatic rings, it will be indicate that more bulkiness. More bulkiness means in this particularly it produces the antihistaminic effect through the H1 receptors. Okay, that is the main thing. That's why the basic structure, in the basic structure bulky group is necessary. Now you can see in this case when you will be see the basic structure, in the basic structure you might be observing to the X group here. X group is nothing but here it might be, you can take X group is nothing but here it might be nitrogen, or it might be carbon, or sometimes it might be oxygen. Okay, it might be oxygen, like that. We are different atoms we are going to be choose in the two heteroatoms. One is the nitrogen, another one is the oxygen. Okay, then along with that you might be observed initially what will be have the aromatic ring was 1 and aromatic ring 2, means both the rings are present which are aromatic, that is AR1 AR2. Okay, then that will be attached to the X. Then after that you might be observing the here number of carbons, that is I am writing CH2 to the power of n. Here it will be attached to the dialkyl amine, that is specially methyl group. Small groups are better for the antihistaminic activity. Then here this is the basic structure, two aryl groups present. Okay, and along with that here one X group is there. X sometime it is carbon, or it is oxygen, or it is nitrogen. Then it will be having the dimethylamine group, that is the amine group. Here in this case what we are observing generally in the basic structure, when you will be see this one, we are dividing into the three parts. This is one part, and the linked chain that is from linked chain, that is from here to here. This is one part, and this you might be observing particularly this groups AR1 and AR2, that is the aryl group. Okay, those aryl groups we are discussing at the, this is the part 1, both the aryl groups here, both the aryl group, and you might be observing this is the part 2 and this is the part 3. We are discussing SAR in the three parts. What is the role of all these three parts? Then generally when you will be seeing this case, always the bulkiness is there. Bulkiness means here you might be observing AR1 and AR2, both are the phenyl, that is required for the antihistaminic activity. And that is the reason I told the basic structure is very important. Basic structure means alkyl groups, aryl groups, okay, and as well as the linked chain, as well as the tertiary nitrogen. These are playing the vital role. These three parts also playing the vital role in the SAR. We will go for the first one, AR1 and AR2 substituents. In this case you might be see either you might be take phenyl ring, you might be take, or benzyl you might be take. This is the phenyl, I marked with the yellow. This is the phenyl, this is also phenyl. See in this case this is called as the benzyl. Benzyl is nothing but benzene, then CH2 here linked with nitrogen. That's why this is called as the benzyl. This is called as the phenyl. Here you might be observing phenyl also there, benzyl also there. Then which one you will be think more active? here the majority of the, when you will be see all the compounds like H1 antagonist, particularly first generation, either second generation, when they will be having the phenyl ring, benzene ring, they are showing the more activity than the benzyl, but irrespective of the other substituents, that is the linked chain and as well as the tertiary nitrogen, this linked chain and tertiary nitrogen, irrespective of that I am not considering that, just I am considering the AR1, AR2. Okay, now see, that is the reason here the you might be observing phenbenjamine, this is called as the phenbenjamine. This phenbenjamine, it is having the both are the phenyl groups. Okay, that's why I wrote here both what they are having, both they are having the phenyl group here. This is also phenyl group and this is also phenyl group, both are the phenyl only. Okay, but in this case here just one change is there in this case. What you are observing, that change here, the heteroatom is there, that is nitrogen. Always just remember that in any SAR, if any heteroatoms are there, any toxophoric groups are there like sulfur, nitrogen or halogens, the activity it will be goes on increase. Remember this point. What? Whenever it will be having the heteroatoms in the aromatic ring, remember that heteroatoms like nitrogen, like oxygen, like sulfur, or any other atoms. Other atoms means like halogens. All they are responsible for what? Increasing the activity. Okay. Now tell me which one is more active here? Phenbenjamine or tripelamine? The easily we can say tripelenamine is more active. This is more active. Why this is more active means? The reason is that already I told here, it is having the heteroatom. Due to this heteroatom, it is more active than the other drug. Which type of activity we are going to be observed? Antihistaminic activity. Remember that, antihistaminic activity. Okay, then that also okay, I told that if it will be having the heteroatom, it is more active, but the position is very important. Which type of heteroatoms? It's called as the pyridine, when it will be having the nitrogen, benzene. 2 pyridyl or 3 pyridyl or 4 pyridyl. In that case it is the 2 pyridyl, because this is the first position, this is the second position. If it is 3 pyridyl means like here third position, here fourth position, here fifth position, here sixth position. Then here 2 pyridyl means the second position substitution to that pyridine ring, it is more active. If it will be having the substitution at third position or substitution at fourth or substitution at fifth, activity it is going to be decrease, not at the sixth, because sixth again it will be considered as the from this side second only, this also considered as the second only, but specially which position? Third, fourth, fifth. Any substitution, pyridyl, any heteroatomic rings or any aromatic heteroatom ring, if it will be substituted means second substitution more active, third substitution less active. You can write here which is more active, this pyridyl here. What I told, which is more active? Second substitution, second pyridyl. Okay, this is 1, this is the 2. Second pyridyl is more active than the third, then the fourth, then the fifth. Okay, not the sixth. Sixth again we are considering as the second only from this side. Okay, that's why if this position second substitution, it is more active. Okay, any second substituted heteroatoms aromatic ring you can replace to increase the antihistaminic activity. Okay, now you can see the next point. What happens in this case? I told that here it will be having the aromatic ring, heteroatomic ring, here it is having the phenyl ring. Okay, in any compound either it might be the AR1 or it might be the AR2. Okay, whatever it might be, whenever the phenyl ring is present, phenyl is nothing but benzene. the benzene to that benzene particularly, the substitution should be at the para position, that is fourth position. Okay, it should be at the para position. This is called as the para. Okay, what position it is called? Para position, because this is the ortho, this is the meta, and this is the para position. Okay, it means para position substitution to the phenyl ring, any phenyl ring. Okay, at the fourth position substitution will be there, means like electron withdrawing group, like you can take the methoxy group or you can take the chloro group, any halogen you can take. Okay, all these things, either it may be the nitro group, all this responsible for the increasing the activity. But which position you have to be remember that only at the para position, only at the fourth position, this position only, fourth position only increases the activity, this fourth position only. Any other position like second position, third position, fifth position or sixth position, the activity it is going to be decrease, means second or third or fifth or sixth, substitution will be there, means activity decreases. Which position activity increases? Only at the fourth position, any substitution, the activity it is going to be increase. What substitution there should be? Either methoxy, chloro or nitro. Okay, I hope you might be understood this point. Okay, next point you can see here. Okay, fifth point I didn't discuss. You can take diaryl pattern. Diaryl means in any all the compounds means either it may be, you might be take that is the first generation antihistamine and second generation, all they will be having this diaryl compounds. See, diphenyl. Okay, this diphenyl is common, either it may be first generation or second generation. Okay, both this diaryl pattern, okay, diaryl means AR1 and AR2. This is important for the antihistaminic activity. Remember that, important for what? Antihistaminic activity. If this diaryl pattern is there, means it is not active. If this is not there, means the compound is not active. Not active in the sense what? It won't show the antihistaminic activity, means no antihistaminic activity. If it is not there, means, okay, that one you have to be remember. That's why AR1, both AR1, AR2, these are important, very important to show the antihistaminic activity. Next you can see, already I told, one is phenyl AR1, another one is the benzyl. Benzyl means this one, this is the benzyl group. Benzyl group means always it will be having this link CH2 to the phenyl. This is called as the benzyl. Okay, then another thing you might be observing, here heteroatom is there, here also heteroatom is there. Okay, then you can see to this benzene halogen is there, here methoxy group is there. Both are electron withdrawing only, methoxy also, halogen also. It is almost similar, and here it will be having the nitrogen, but here it is having the carbon. But when compared to the benzyl, this biphenyl is more active. More active. Remember that. That's why chlorophenyramine is more active than the pyrilamine. This is the pyrilamine. Okay. Why means the reason I told you. Here it is not the benzyl. This is the benzyl, extra carbon. It is decreasing the activity. But here there is no extra carbon attached. Otherwise remaining structure is same. Okay. That's why it is chlorophenyramine is more active than the pyrilamine. Okay, this is about the AR1 and AR2. Okay, first what I told, AR1 or AR2, both they will be having the aromatic ring. In that one should be, one AR should be the heterocyclic. Heterocyclic means it will be having the heterocyclic atoms in that ring. Heterocyclic atoms always increases the activity. AR2 means there is the phenyl group. To that phenyl group, para position. Which position I told? Para position, like this. It is also responsible for like this. Para position always increases the activity. Remember that. What it will be increases? Activity will be increases the activity. Okay, I think it is clear. I hope so. Then we will be go for the next, our second part, that is the connecting chain. See the connecting chain here, you might be observing. This is called as the connecting chain. Don't be confused. In between the nitrogen and two aromatic ring, whatever the chain is there, this is called as the connecting chain. The connecting chain, this all both the aromatic, particularly aromatic rings, they are connected to the particularly this terminal amine. Okay, they are connected. That may be X is nothing but sometimes they might be having the CH2, sometimes they might be having the methoxy. Methoxy means this linkage is called as the ether linkage. What it is called? Ether linkage. This is the ether. Okay, there might be sometimes nitrogen will be there here, sometimes oxygen will be there here. Okay, sometimes carbon will be there. Means based upon the other positions, the activity it will be shows the difference. Dramatically it will be showing the difference. Okay, but what type of difference it will be show, that is the different case. Okay, but generally the link whatever it might be there, that link should be minimum, it will be having the 2 to 3 carbons. Remember, this is very important. If it is less than 2 carbons, then what happen? Decrease the activity. If it is okay more than 2 carbon, decrease, sorry, not more than, less than, sorry. If it is less than 2 carbon, decreases the activity, and sometimes more than 3 carbon also decreases the activity or completely abolish the activity. Remember that. That's why the produce the optimum activity means how many carbons will be required here? 2 to 3 carbons. How many? 2 to 3 carbons to produce the optimum activity, that is the optimum antihistaminic activity. See here, the many linkages are present, particularly in this case. Okay, you will be seeing here oxygen is there, here nitrogen is there, here no heteroatom substitution is there. All they are playing the vital role, all they will be required. Okay, but what I told, longer than 2-3 carbons decreases the activity, shorter than 2-3 carbons also decreases the activity. If it is long, more than 3 carbons, decrease the activity, less than 2 carbon also decreases the activity. Optimum activity only for the in between the number of chain, number of carbons in the chain, the length of the chain should be 2 to 3. How much? 2 to 3. Okay, that's why you can see here optimum activity. Okay, when it will be having the 2 carbons, 1 carbon C reduces the activity. The activity is poor because it is going to be fit less with the receptor, not flexible with the receptor. If it will be having the 3 carbons, more flexible with the receptor. 3 carbons, you can see 1 carbon binding with the receptor, the some activity increases. 2 carbons, more activity. 3 carbons, again it will be the more flexible, more binding, but the optimum binding only for the 2 carbons. 3 carbons also flexible, it will be bind, but it is less active. Okay, 3 carbon compound always less active when compared to what? 3 carbon chain is less active when compared to the 2 carbon chain. It means what? Always 2 carbon chain having the more activity. Remember that, more activity. Okay, next you can see there Sometimes in the side chain there will be the two nitrogens. How it will be? Here you might see one aromatic ring AR1, here you can see AR2. Okay, here sometimes here one nitrogen, then the two carbons. Okay, then you can see here one nitrogen, then that particularly R1 and R2. What you are observing this. Okay, in this case generally here what I am going to say exactly means, in this case one nitrogen should be more basic. Which is more basic? Here, which will be attached to the aromatic ring, not that one. Basicity will be increases when it will be having the lower alkyl groups like methyl. Here always any compound you might be take, the majority of the compounds R1 R2 R1 and R2 are the, you might be observing, they are the methyl. It means what here? Terminal carbon should be, whenever terminal nitrogen is there, this nitrogen is more basic. It means what here? More basic, strong basic nitrogen means it produces the more activity. That is very essential. This nitrogen should be in the form of tertiary and should be strong basic. Remember this point. Okay. Then you might be seeing this case what happens sometimes means here in the connecting chain. Here I told that two nitrogens, sometimes it will be there, here one nitrogen and here one nitrogen. Okay, and sometimes what happen means in the piperazine also two nitrogens are there. Piperazine means this particularly here. How it will be I will show by writing. Here you can see carbon, carbon, here especially. That also having the two nitrogen. This is called as the piperazine structure. This is the piperazine. In that also nitrogens are present. But which nitrogen is more important for us means this terminal nitrogen. Okay, that will be shows the more activity. Okay. But in the piperazine there are the more nitrogens. What I told, more nitrogen, more toxophoric group means the activity will be increases. But that is depending on the other composition. Sometimes more nitrogen also it is not good for that particular structure. That's why some optimum contents will be there. Component should be there. Like I told 2 to 3 carbons necessary in the chain. Here also one basic nitrogen it is more comfortable. 2 nitrogens also it is somewhat comfortable. When it will be having the 3 or 4 nitrogens, the activity it won't be increased, it will be decreased. Along with that toxicity also will be increases. Okay, you might be understood. That's why the orientation of those nitrogen is very important. Okay, when it will be having the terminal one nitrogen, it is more active. 2 nitrogen also produces the optimum activity. But when it will be having the 3 nitrogen, when the orientation is not correct, orientation means place of that nitrogen is not correct, means decrease the activity. Remember that. That is the another point. The next thing is that we might be know that in the side chain nitrogen will be there or other atoms also there. Okay, but I told it should be more basic to the more active. Then the another thing is that here you might be observing in this compound there is the double bond. Just see what is the double bond. Always double bond, what it will be shows around the doubly bonded carbon, this side 2 atoms, here nothing is there means hydrogen is there, don't be confused there. Okay, it is in the form of cis, it is in the form of trans. How it is in the form of cis, how it is in the form of trans? See, higher priority group, similar site, same side, this will be called as the cis, represented by the Z. See, the higher priority groups, opposite side, this side one, this side one, opposite side, okay, opposite side. Opposite side means it is like this, okay. Same side means like this side and this side, but here opposite side, this is called as the opposite side. Opposite side means it produces the E isomer. In this case, you have to be remember one thing, the E isomers means which are opposite to each other, to the doubly bonded carbon here, okay. Then what it will be telling, that E isomers are 1000 times more active than the Z isomer. See the stereochemistry, how it is playing the vital role. That is called as the geometrical isomerism. Sometimes trans will be more active, sometimes cis will be more active, but here cis will be more active, okay. Sorry, trans will be more active, not the cis. This trans is 1000 times more active. How many times? 1000 times more active than the cis compound, okay. You have to be remember when it will be having the double bond in the side chain. Which one is more active? Trans will be more active, that also 1000 times more active than the cis. Remember this point. Next, you can see always the branching. More branching, it is going to be decrease the activity. Except promethazine, phenothiazine. Phenothiazine, it will be having the branching. That is the beta carbon branching. You might be observing here. I wrote the beta carbon. This is the beta carbon. This carbon is the beta carbon. Which carbon? This one is the beta carbon. Okay. On the beta carbon, whenever the branching will be increases, what happen? Branching increases. Already I told, in the branch how many components should be there? 2 to 3 carbons. 2 to 3. More number of carbons means more branching, like this. More branching in the other compounds, not in the phenothiazine. Remember that branching in the phenothiazine, like this compound, increases the activity. But other compounds means previously we discussed where this type of compounds branching whenever increases more than 3 carbons, decrease the activity. It indicates that here also same branching, but in case of phenothiazine, like promethazine, branching increases, activity increases, but in the other components, branching increases, activity, antihistaminic activity decreases. But you have to be remember here, except phenothiazines. Phenothiazines branching will be good. Other component branching will be decreases the activity. Okay. Then the another thing is that you might be observing the substitution in this case. In the basic structure, we might be observed sometimes the aliphatic substitutions in place of R1 and R2. Okay. Sometimes what happen, R1 and R2 place aromatic substitution. Sometimes aromatic substitutions, sometimes aliphatic substitutions. Here, particularly for the cyclic amines, what happen? There will be the conformation restriction. Conformation restriction means, for example, you might be think this nitrogen here, it will be cyclized like with the piperazine. Okay, it is cyclized here with the piperazine. Means rotation will be decreases, atom rotation will be decreases. When it will be decreases, activity will be increases. Remember that. Either it should be have the methyl group. If it is having aromatic ring means it should be more basic means it should be have the heteroatoms in the ring like this. When it will be having the heteroatoms, it make more basic. That is one point. Okay. Otherwise it should be aromatic here. Aromatic means that is the conformational restriction occurs, means rotation will be occur. It is not free. Cyclic form it will be rotate like this. It won't rotate. If it is in the free form like this, it is rotate or not? It is going to be rotate. But it will be goes in the cyclic form, the same compound means it will be rotate. No rotation. No rotation. But when it is in the free form, rotation is possible here. It causes rotation. Okay. That's why this aromatic particularly when it will be cyclized the terminal nitrogen, then the activity what happen when it will be cyclized, the activity it is going to be increases. But if it will be having R1 R2 are the alkyl groups like R1 and R2, both are the methyl. This also produce more activity, more active. But the problem is that this is causes the sedation. What it causes? Sedation. But when it will be converted into this form, cyclic form, this is in the second generation. What decreases? Sedation decreases, but activity increases. Remember that. Sedation decreases, activity increases. This is about the linked chain. Then basic nitrogen what I told. Okay. Then here it should be in the form of tertiary. This should be in the form of tertiary. It is in the form of tertiary because here one substitution, here one substitution, here one substitution. To the ammonia, 3 hydrogens also substituted. That's why this nitrogen is called as the tertiary. Always you remember that tertiary are more active than the secondary. Secondary are more active than the primary. Which one is more active? Tertiary. Potency order will be like this as a given. Tertiary more active than the primary. Secondary more active than the primary. Okay. But here you can be use the quaternary compound also. Quaternary compound is nothing but another substitution will become fourth substitution R3. This is called as the quaternary. Quaternary always decreases activity because what is the reason? It is orally inactive. Remember that. Orally inactive. Which one? Quaternary. This is called as the quaternary. That's why what produces optimum activity? Tertiary produces optimum activity. Optimum activity. Okay. Which one? Tertiary produces optimum activity. But quaternary what happened? Inactive. Okay. Remember this point is very important. Okay. The number of nitrogens. Here already I told. One basic nitrogen it is essential. One basic nitrogen like this terminal. Because it is act as the binding, a protonated binding center. Easily it will be go bind with the receptors. That is one reason. Okay. If it will be having the more nitrogens. Okay. More nitrogen means it should be have to be go in the form of cyclization. Like piperazine. Piperazine derivative of the antihistamine. If it undergoes the cyclization, then the activity you can say it is going to be increase. But if they are in the open form, open chain form and more nitrogen, you might be think here one nitrogen, here one nitrogen, in the another compound one more nitrogen, more nitrogens open chain form, more nitrogens, but open chain form. decreases the activity. Remember that. Okay, one nitrogen should be there at the orientation should be at the correct place. If it is present at the right place, it produces the more active. More nitrogens at the wrong place, the activity it will be decreases. Those will be less active. Okay, because you might be know that, for example, like citrazine, piperazine, there will be the polarity will be more in those compounds. That's why it is not going to be penetrate into the central nervous system. Okay, easily not going to be penetrate. Too many nitrogens, what they will be do means increases the polarity, reduces the lipophilicity, binding affinity decreases. It means poor penetration into the CNS. It means it produces the less activity. Okay, but even they are less penetration in that to the central nervous system also, if it is in the form of cyclic, then the activity it is going to be increases. Why increases means there will be the conformation restriction will be there. That's why, that is the reason. Okay, here if it will be more nitrogens, decreases the activity. Okay, increases the polarity, it makes compound less active and less bind with the receptors. But one nitrogen should be there, that will be at the correct position, means increases the activity. Other nitrogens, more nitrogen should be there, means no problem, but it should be in the form of cyclic. More nitrogen, cyclic means more nitrogen, cyclic means increase activity. Okay, increases the activity, increases the activity. Okay, but more nitrogen not in the cyclic form means nitrogens are more nitrogen but not cyclic, means what I told, decrease the activity. Then the what type of substituent should be there on the nitrogens? I told that small groups like the methyl groups increase the activity. But if it will be having any bulky groups at this nitrogen, for example, you might be think on this nitrogen there will be the bulky groups like this isopropyl or isobutyl group. What they will be happen? They are going to be cover this nitrogen completely, it will be shield that nitrogen. When they will be shield this nitrogen, what happen? When they will be shield this nitrogen due to this group, there is no binding with the receptor, no binding with receptor. That's why what type of group should be there? Small alkyl group should be there. Small alkyl groups, what happen? Increases the activity. Larger substituents means steric hydrants produces, they will be cover that nitrogen. Okay, already I told, if it is in the form of quaternary, does not increases the activity. Quaternary, what it increases? Increases the anticholinergic activity. But the quaternary means in the antihistaminic, that is orally active, inactive. But quaternary is good for the anticholinergic, not good for the antihistaminic drugs. This is about the SAR of the H1 antagonist. Please, one request from my side, subscribe the channel, like it. By the subscribing your my channel, I'm not going to be richer and richer, okay, with your subscription, but it's my passion. Whatever I'm doing, with the passion only I'm doing. I'm not thinking about the generation of the income with this channel. Please subscribe it, like it. Whatever I have the knowledge, it should be how to be reached to the maximum people. Thank you very much.